Emergence of new human pathogens are often associated with rural areas, where people have frequent contact with animal reservoirs of zoonotic infections. Cities, in contrast, are often the reservoirs or core areas for many established human pathogens. Cities can provide more robust chains of transmission, both because of increased contact rates and because of the greater supply of susceptible individuals. Cities are essential arenas for both the evolution and ecology of human infections. It is believed that many important pathogens only established in humans following the Neolithic revolution around 10,000 years ago, when early humans made the first settlements that eventually grew into early cities some 3,000 to 5,000 years ago. These include species jumps by smallpox, tuberculosis, measles, whooping cough, and probably most other acute immunizing infections that would rapidly fade out in the sparse pre-settlement human populations. Transmission in cities was particularly rampant in the beginning of the Industrial Revolution during the early part of the 19th century. Workers often lived in very crowded, unsanitary conditions, in which contagion of tuberculosis, typhoid, and cholera was rampant. Tuberculosis alone causing up to 25% of all deaths in many cities. In early industrialized cities like Liverpool and Manchester, the death rate from TB was 10 times that of the surrounding rural areas. The death rate from childhood infections like measles and whooping cough was 4 times higher. Mortality rates on the whole were 50% higher than the national average. Sanitation, vaccination, and urban health infrastructure have greatly altered the abysmal situation of the past. However, big cities still play an important role in the dynamics of many infections. Most epidemics of immunizing infections, for example, quickly burn out in smaller towns or villages because they run out of susceptible individuals to sustain the chain of transmission. Such infections can only persist in communities above a certain size, or really in communities in which the birth rate of unvaccinated children is sufficiently high. Dynamically speaking, this leads to what is called island-mainland metapopulation dynamics. In ecology, a metapopulation is a group of local populations or communities connected by infrequent movement amongst them. In island-mainland epidemics, the pathogen retreats to a few big core cities during interepidemic periods, allowing the susceptible populations to build up in smaller communities. Intermittently, when susceptibles are numerous enough for the effective reproductive number to exceed 1, the pathogen can spread through smaller communities to cause broad-scale epidemics. This type of dynamics is clearly illustrated by pre-vaccination measles. In interepidemic periods, measles was only present in less than 10 big cities. During the major epidemic that happened every 2 years or so, measles was present virtually everywhere. The spread out of the big cities happens in a very characteristic hierarchical fashion, where on average the timing of epidemic happens in an order of descending size and increasing isolation. This timing comes about because of key characteristics of human mobility, by which movement is more frequent between big cities and more frequent between communities close together. We see similar patterns of what is called hierarchical diffusion in many other childhood infections, as well as seasonal influenza. While this type of spread is inherently random, we can predict the relative risk of outbreaks using the so-called gravity models of human mobility. Today, in many European countries, vaccine cover is high enough that no cities are big enough for sustained transmission of measles. However, in contrast to the Americas, where measles is eliminated, measles persists regionally by jumping from city to city, causing epidemics that quickly die out locally. In disease ecology, we call this metapopulation persistence, as opposed to the more conventional local persistence that relies on unbroken chains of transmission in each host community. Rabies in raccoons and plague in prairie dogs are examples of animal diseases that only can persist at the metapopulation level. Since the movement of wild animals are simpler and do not rely on complicated human transportation networks, we often see spatial waves of spread of rabies and plague that are reminiscent of forest fires.